Now, what is a projectile motion? Projectile motion is if you project an object at an angle or horizontally, but it takes the object takes a parabolic path. So that's called a projectile motion. Example, right? Let's say this is a cliff, and we actually project the ball horizontally with speed v. So what will happen to the path of the ball? The ball will take a parabolic curve. So this is a projectile motion. The second type of projectile motion is when this is the ground, and then you project the ball at the angle theta from the horizontal with speed v. So what will happen to the path of the ball? It will also be a parabolic path. So what will happen is you will notice that this path is also parabolic, this is also parabolic. So this one is actually half of this. Alright, so this one is actually half of this. So when will you get a parabolic path? You get a parabolic path when the acceleration is fixed at one direction, but your velocity keeps changing direction. Example, when the ball is traveling along this path, the direction of its velocity, because velocity is a vector, right? How do we get the direction of the velocity at this point? It is always tangent to the curve. Do you understand? Then when you reach this point, your velocity is also tangent to the curve. But your acceleration, isn't it due to gravity alone? So you will notice that the acceleration of gravity is always downwards, right? Not? Do you agree? So you will get a projectile motion if you send an object at either horizontal or angle, but your weight, which is your acceleration, is only one direction, which is vertically downwards, and it is constant. So you have a constant acceleration of g vertically downwards all the time. Then you get a projectile motion. Even in the next case, the second case here, when you reach here, your velocity is also tangent. You reach here, the velocity is also tangent. But what happens to the acceleration? Acceleration is always g. And remember, acceleration of gravity is always vertically downwards, so you will get projectile motion. Do you understand that? So because an object which is undergoing projectile motion is actually moving in a curve, so when we want to solve it, we have to resolve the motion. That means we have to solve the horizontal motion separately, and then we solve the vertical motion separately. You cannot solve them together. But some quantities, they will be common for both, which is the time taken, that's it. But when you solve horizontally, all your velocities, your acceleration, everything must be horizontal. When you're solving vertically, then all your velocity and the acceleration must be vertical. You cannot mix them up together. For example, let's look at the first case here first, which is this side. When the object is traveling through the air and we want to solve horizontally, so let's take to the right as positive. So we're going to solve horizontally, taking to the right as positive. Now, are there any forces acting horizontally on the ball? Now, the moment we give it an initial speed, we don't call it a force because we're looking at the speed. So we're giving an initial speed. As the ball is flying through the air, are there any horizontal forces acting? Some people say air resistance up. So for the purpose of calculation for our A levels, we will ignore air resistance. Okay? We will always assume air resistance is negligible. So if your air resistance is negligible, that means there will be no horizontal forces acting, right now. Because what is the only force acting when the ball is traveling through the air? Only the weight. Only the weight is acting. Because whether you got air resistance or not, weight is always acting. So you only got weight, and weight is which direction? Therefore, horizontal got no force. So because horizontal has no force, when you solve horizontally, you will be constant velocity. You understand that? So, and remember I told you, if the object is traveling at constant velocity, can we use kinematics equations? No. What equation can we use? Only one, which is distance equals to speed times time. That's all. So your only equation will be distance equals to speed. Speed times time. So let's call the horizontal distance x will be equal to v times t. Okay now, that's it. No other equation. Alright. Now, if you are solving vertically, then we can think about this. If you are solving vertically, now which direction should we take as positive? Downwards. So if you take downwards as positive, alright, let's take it downwards as positive, then it will be constant acceleration. Okay, now, and constant acceleration means we can use any of the kinematics equations. So if I write v equals to u plus at, so you will get vy. Now what is my initial vertical speed? 0, because I'm projecting horizontally. That's what I'm trying to say. So it will be 0 plus gt. Why I use plus? Because I'm taking downwards as positive, and acceleration of gravity is always downwards. Understand? Now you can use any of the kinematics equation like this. But just remember that your initial vertical speed is always 0. Okay? Now, for the second case here, let's do again. Now, horizontally. So once again, it will be constant. Constant? Constant velocity. So if it is constant velocity, then what is the only equation I can use? Distance equals to speed times time, which will give me what? X equals to, now there's something special, because your speed is not horizontal. Your initial speed is not horizontal. It is speed v at the angle theta, right? So you have to resolve the speed into two components, v cos theta and v sin theta. So what is the horizontal component? What is the horizontal component of this speed? V cos theta, right now? So your equation will be v cos theta times t. You see the difference between this and this? This one is just projecting horizontally. That's why you just vt. But this one at the angle, so it's v cos theta times t. Understand? But if you were to solve vertically, so which direction should we take as positive? Up or down? Initial direction is up or down? Up. So you must take up as positive. So we'll take upwards, and vertically, remember we have constant what? Acceleration. So you can use any of the kinematics equation. Example, if you use v equals to u plus at, so what is my final vertical speed? Is vy. So your initial vertical speed is how much? U is what? V sine theta. Why? Because you are projecting the object at the angle. So initially, does it have a vertical component, which is v sine theta, right? So it's v sine theta. And your acceleration must take negative because your upwards is positive, so it's minus gt. Another example. Let's say we use v squared equals to u squared plus 2as. So vy squared equals to what? What is your initial vertical speed? V sine theta minus 2gy. Do you understand that? Okay? So the idea that I want you to know is that whenever we solve horizontally, whether it is for this or this, is always constant velocity. So there's only one equation. But when you solve vertically for this or this, it will be constant acceleration. But there's a difference. You are solving for this type, your initial vertical speed is always 0. But you're solving for this type, you will have an initial vertical speed. Understand? Alright, so that's how you solve projectile motion. Now, the time taken for you to move, right, let's say from here to here, so you can split it. That means it will be the same as the time taken to travel horizontally from here to here, which is the same as the time taken to travel vertically from here to here. That one is the same. Okay? Now, a very good illustration of this projectile motion. Alright, I'll show you the next slide. Now, the next illustration I'm going to show you help you to imagine the projectile motion. Now, have you heard of the story of the monkey and the hunter? Never, right? So, the story of the monkey and the hunter goes like this. So, let's say you have this tree here, and there's this branch here, and the monkey is hanging from the branch. Okay, this is supposed to be a monkey lah. Okay, something like this lah. Huh? It's not. Okay, it is lah. So now let's say you have a hunter standing or standing here. Wait, I show you something a bit easier lah. So let's say standing here. Alright, oh sorry, the hand wrong. So it's holding a bow and an arrow. And aiming where? And actually it is aiming right at the head of the monkey. Oh, very violent. Okay, but so what the monkey thinks is like this. He thinks that the moment the hunter releases the arrows, since the arrow is pointing at his head, he will release his hand. The grip from the tree, so he will release his grip here and he will fall. And because he falls, the arrow will pass over his head. That's what he thinks. Okay, so what do you think happened? So as he fell, this arrow will undergo projectile motion as well. So that means when the monkey fell, suddenly become bigger. Okay, the arrow undergo a projectile motion and will hit his head exactly. You understand? So why am I showing you this? It's because the vertical motion of a projectile motion here is similar to an object falling or going up and coming down. It's the same. Do you understand? So it's exactly the same. So some people find this hard to imagine. So I tell them, if you use a non-violent one, you can go to the the archery there, and let's say you're aiming at the bullseye. Okay, so you aim the arrow exactly at the bullseye. Now, do you think you will hit the bullseye if you release? Definitely no. Why? Because you undergo projectile motion and you will fall. So if you want to hit the bullseye, you must actually aim slightly higher. Because after projectile motion, then you will hit the target. Or there's an alternative. You ask your friend to hold it. Hold the target. Now, the moment you release the arrow, you ask your friend to drop the target. So as your arrow moves in a projectile motion and your target falls, it will hit exactly the bullseye. You can give it a try afterwards. Okay. Why? Because the vertical motion of this arrow, which is from here to here, so the vertical motion is actually just arrow falling. It's the same as your target falling. That's what I'm trying to show you. So that's why when you solve projectile motion, you just solve as if for the vertical motion, you just solve as if you're either dropping the ball, if you're projecting horizontally, so the vertical motion is just falling. If you're projecting at the angle, then how you will solve vertical motion is as if you throw a ball up into the air and falling back. It's the same. No difference. Okay?